All right, number 10, we've got some kind of a pipe assembly here that I want to look at. And what I want to point out is, okay, well, first pause the video and study the drawing. Make sure you kind of get your head around what's happening in the drawing there, okay? At A and B and C, all right, it says a smooth journal bearing. So what does that mean? That means that the pipe goes in here, all right, and it can spin freely and it can move in and out freely. Okay. So Z, for example, can only provide a force in, sorry, A, for example, can only provide a force in the ZY plane. Okay. So it could push off in this direction, up the other way. Okay. Something like that. It just can't push along the pipe in any way. Okay. So in that direction, there's no friction. It also cannot provide any moment. Okay. So we've got three of those kinds of bearings just like that. And so there's some pretty severe limitations on the direction of our forces because of that. Okay, so first job, we want to put in how we think the supports are going to behave. And okay, so I talked about this in 2 dimensions, and I said when you do this, you're really making a guess, okay? And your guess could turn out to be wrong. If your guess is wrong, then that means you just got it backwards, okay? So in 3 dimensions, that can happen also. All right. So my guess initially here, we've got the 450 down, is that C is going to have to be up. Okay. So I'm going to put C in there like this. And I'm going to sort of imagine that B is a little bit like a fulcrum on a teeter totter. And so it has to provide vertical support as well. So there's B. And if the 450 wants to make the teeter totter go down, we need something to keep it down at A. And so I'm going to guess that A is over here like that. So those are my guesses there. Okay. So now I'm ready to use my relationships, some of the forces and the sum of the moments. Okay. I'm going to skip FX and FY because we don't have any forces in those directions. And so that's a complete waste of our time. So let's just get right to what we had before. Okay. And so that is to say, we are interested in the Z components. And as we've drawn them, we're going to have A down and B up. The 450 is down and C is up. Okay, so let me make that look a little bit neater. I've got minus A plus B plus C is 450. Okay, and so there I've got 1, 2, 3 unknowns and one equation. That's all we had. We'd be up a creek. However, we got more relationships that we could work on when we're trying to do that. Okay, so we get to the moment equations. All right, so I'm going to rearrange my paper just a little bit here. Okay, there we go. And let's start with moment around the y-axis. Okay, just like that. And so since A is on the y-axis, we don't get any moment arm for A. So I'm just to help me remember, I'm going to put 0A on there. Now moving to B, B is a distance off the y-axis of 0.6. So I'm going to have 0.6B, okay? And the way B is sitting in there, okay? So get your head around this, use your right-hand rule, get your hand out there and practice. That's got to be negative, Okay. That's got to be negative. So I'm going to put in minus 0.6b. Then I've got my 450, which is if the b going up was a negative, then the 450 going down is going to have to be positive. So I'm going to have 0.6 times my 450. And then at C, it's also in the same direction as B, so it's got to do the same thing. So it's going to be negative, but it's out there at a distance of 1. So we've got minus 1C. All that's equal to 0. Okay, so let me simplify that up. Okay, and once we do that, we've got 0.6b plus C has to be equal to 270. Okay, so there's that one. All right, so now I've got another relationship for two of my variables. I need one more. No problem. We have a whole nother equation to work with. And so we've got M. Woo, we just did that one. We want to do this one. MZ equal to 0. Okay. Oh, no, 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 no. Sorry. MX equal to 0. Okay. Again, A is right there on the x-axis. And so just to help me remember, just for the sake of clarity, I'm going to put 0A. The point B is at a distance of 0.6. So I got 0.6B. Is that going to be positive or negative? Well, okay, that's going to be positive because it naturally goes in the curl direction of my fingers when my thumb is along X. So that's positive, which means the 450 is going to be negative, and it's out there at a distance of 1.2. And then finally, we've got C, and C is out there at a distance of 1.2. It's in the same direction as B, so it's going to have to be positive as well. So I've got 1.2 C, and that's equal to 0. Okay, and so if I simplify that up, I'm going to get 0.6 B plus 1.2 C, and that has to be equal to 540. Okay, there we go. Now, there's our third relationship. So we've got enough equations to come up with answers. All right. And if you execute that, what you get is you get that A. Oops. I need to make it a little bit bigger here. A is negative 900. B is negative 1800. And C is 1350. Now, those are a little bit odd. What does that mean? Well, let's start with C. What that means is that we guessed the correct direction for C, okay? We guessed that it was up, and it is in fact up, okay? So if we were going to write C as a Cartesian vector, what we would do is we'd say C is 0, 0, 1350. Okay? That's what we've got right there. Now, B, we guessed up, but the answer we got was negative, which means we guessed exactly wrong. Okay, got it in the wrong direction. So that means B, if we were going to write it, put a little thing over there, we would write 0, 0. It's not up, it's actually down. Okay, minus 1800. Okay, and A, I need to pull this down a little bit. A, we guessed down, but we got a negative number, so it's the opposite of what we guessed. And so if we were to write A in Cartesian coordinates, it would mean we've got 0, 0, 900. Okay. So when you get these negative signs, that simply means your guess was opposite. Okay. It doesn't necessarily mean, okay, don't jump right away and say, oh, well, hey, we got a negative here, so it's got to be negative over there. That's no, 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 no. Don't do that. That would be a mistake. Okay. It just means it was opposite of your guess. Okay. So, like here, we got negative 900. Well, it's positive over here because we guessed in the negative direction. It's negative of the negative, which makes it positive. Does that make sense? Okay. So, anyway, I've told you a few times that, if you do guess wrong, it'll come out in the wash. And there's a great example for you. And that's legit. Okay, those were my when I worked this out on paper, those were my guesses. I guessed down and I guessed it wrong. I just guessed it wrong. And everything in my gut told me it made perfect sense. Okay. And so let's not I'm gonna try not to go off on a tangent about when people say just use common sense because more often than not, common sense is wrong. Okay, that's why we study algebra. That's why we study engineering. Okay, because our common sense can trick us. Anyway, that's what happens. And if you get a negative number in your answer, it's not a big deal. Just work it out. If I guess to the left, well, then it's actually to the right. If I guess down, then it's actually up. Okay, easy fix. No problem. Okay, let's get a woo. I wanted a bird's eye view. I didn't mean that much. Okay, but you could see again the pattern, what we've done. We summed the forces and we summed the moments. We got three equations for our three unknowns, and then we had to solve those somehow using our calculator, using Wolfram Alpha or whatever. Okay. Anyway, there you go. Not so bad.